Unit 5, Objective 4 is the study of the normal model. Now, you probably know this more commonly as simply a bell curve. But in the world of statistics, it has a specific name, and it's called the normal model. Now, the normal model right here is divided up into sections, and each one of these sections represents a standard deviation. So, normal modeling follows what we used to call the empirical rule, and some of the newer textbooks call it the 68, 95, 99.7% rule. And all this is telling us is the amount or the percentage of data that belongs in each one of these sections. So my first section, 0 represents the mean or the average of the data. If I went one standard deviation up and one standard deviation down below the mean, the rule is telling us we have trapped 68% of the data points. So 68% of the data falls in this section right here. Now, because the curve is symmetric, it's really easy just to divide that by 2 and say this is 34% of the data right here, and this is 34% of the data right there. Now, here's where some math comes in from here on out. The rule says if you go from one standard deviation up and down to 2 standard deviations up and down, you're now at 95% of the data. 95% of the data falls within -2 and +2. Well, we've already accounted for 68% of it right here. So we have to subtract that 68, and we get 27. So by going from plus and minus 1 to plus and minus 2, we've actually increased our percentage by 27%. Because it was 68, now it's 95, but half of that 27% belongs here, and half of it belongs here. So divide that by 2, and you get 13.5. So we put 0.135 right here, and we put 0.135 right there. Now, if we want to go from plus and minus 2 to plus and minus 3, we go from 95 to 99.7% of the data. So 99.7. So 99.7% of all the data falls between the boundaries of -3 and +3. But we've already got, at this point, 95% of it accounted for. So we subtract, and we get 4.7. Divide that by 2, because half of it belongs up here and half of it belongs down here. And that gives us 2.35. So as a decimal, it's 0.0235. Now, the only thing that leaves us is how much of the data is outside of the boundaries of plus and minus 3. Well, it's only 0.3%. So we're going to take 0.3 and we're going to divide it by 2, and we're going to get 0.15. So this is, as a decimal, this is 0015, and this is 0015. Now, just to check it, everything should add up to, in this case, 1.0. So 0.0015 plus 0.0235 plus 0.135 another 0.34 plus 0.135 plus 0.0235 plus 0.0015. Sure enough, it equals 1.0. So if you add up all the sections in this normal model, you have accounted for 100% of all the data. Now, this is going to be the building block of a lot of the analysis that we do later on in this worksheet. Now that we have the normal model all broken up into its proper sections, we can start asking questions like this. What proportion of the data lies between a z-score of -1 and +2? So how much of the curve is in this area right here, from -1 to +2? Well, all we do is we add up the sections. This would be 0.34. The next one would also be 0.34. And then we would include this section right here, which is 0.135. So we've got 34 and 34, which is 68, plus 13.5, so 81.5. It's 81.5% of the curve. But the question was asked in proportions, so it's actually 0.815. If you add this plus this plus this, you get 0.815. Now the next question, how much of the curve is above a z-score of 1.0, of 1? How much of the curve is above a z-score of 1? So we just want to add up all the sections that are above 1. 0.135 plus 0.0235 plus this little section of 0.0015. And we get 0.16 or 16%. Here's our first example of working with the normal distribution. An athletic conference made up of 10 large universities reported the maximum weight that each member of their football teams could bench press. The data followed a normal distribution with a mean of 265 pounds and a standard deviation of 30 pounds. And so here's the notation right here, the mean of 265 and the standard deviation of 30. Now there's going to be a series of questions asked about this data, but the first thing you need to do is fill out the chart according to the empirical rule with the proper numbers. So this would be 34%, this would be 34%, and then 13.5% in this section, and 13.5% in that section, 2.35% in this section, 2.35% in this section, and then 0.15% after that, and 0.15% down there. Now, these sections are really important to answering actual questions that are going to be asked about the problems. If you're having trouble figuring out where those numbers are coming from, go back and look at the previous introduction to the topic where I explained how we use the empirical rule to get these numbers. Now, what do these numbers represent? They represent different sections of the normal distribution. So the next thing we're going to do is we're going to take the data specific to this problem. Remember, they said the average football player can bench press 265 pounds. So I'm going to put a 265 right there in the middle. And then each standard deviation is a change of 30 pounds. So if I went up, it would be plus. So that would be 295. That would be 325. And this little break right here would be 355 pounds. But I also go down. So this would be 265 minus 30, which would be 235. This would be 205. And this would be 175 right here. Now these boundaries have another number associated with them as well. And that other number is their z-score. So a football player in this conference who can bench press 265 pounds is the average. So his z-score is 0. This is positive 1 right here. This is positive 2. This is positive 3. This is negative 1. This is negative 2. And this is negative 3. So now that we have the chart all filled out, we can start answering some specific questions, like this first one. What percent of all football players in this conference have a maximum bench press between 235 pounds and 325 pounds? So really all we want to know is what's the total amount of this area from 235 to 325. So what we're going to do is we're going to take 34, 235 to 265 is 34% of the data, plus another 34% of the data, plus 13.5% of the data, and we're going to get our answer, which is 81.5%. So 81.5% of all the football players in this conference have as their maximum bench press somewhere between 235 pounds and 325 pounds. Now, I can ask another question, and you see this question on your worksheets. If this athletic conference has a total of 480 football players, how many have a maximum bench press of at least 325 pounds? Well, at least 325 pounds gets us right here and above. So the first thing we have to do is find out what percentage of everybody can lift at least 325 pounds. So it's not that many. It's 2.35 plus 0.15. So from a percentage standpoint, we're talking about 2.5%. But that's not the question. The question was how many. So if this distribution represented 480 football players, what we have to do is take 480 and find 2.5% of it, which is 480 times 0.025, which equals 12. And that would be our answer. My last couple of examples for Objective 4 are word problems which just don't really require a chart. You just need to know the data. I am going to continue with the previous problem. A football player at one of the colleges has a maximum bench press of 210 pounds. What is the z-score for this football player? Now, if you go back here and look at the chart, 210 pounds isn't a specific number on the chart. It doesn't land at one of the z-scores. So 210 is about right here. So we know it should be between -2 and -1. Well, we're just going to use the z-score formula to figure out what this player's z-score is. Z equals the value that we're working with, which is x, 210, minus the mean of the data, which was 265, divided by the standard deviation of the data, which was 30. We should probably recap that. The mean in the data was 265, and the standard deviation of the data in the previous problem was 30. So now all you have to do is get out your calculator, and 210 minus 265 is negative 55 over 30, and do that division. And you do get a long repeating decimal, negative 1.83, and it's the 3's that repeat. So we just usually use 2 decimal places for a z-score. So that would be this player's z-score, negative 1.83. And then what is the meaning of his z-score? I went ahead and typed it in right here. His maximum bench press is approximately 1.83 standard deviations below. And that's important because the z-score was negative, below the mean. And another question, another football player has been told that his z-score is equal to 2.2. What is his maximum bench press? So this is what I call a backwards z-score. We're going to take that z-score formula again, and we're going to substitute what we know. In this problem, we know that his z-score is 2.2. We're actually trying to figure out what is his raw score. So we're solving for x. We know the mean of the distribution is 265. We know the standard deviation of the distribution is 30. So the next thing we're going to do is we're going to cross multiply. So take 2.2 and multiply it by 30, and you get 66 equals x minus 265. So add 265 to each side, and you get 331 pounds. And that's the answer to that problem. A football player who has a z-score of 2.2 has a maximum bench press of 3.31 pounds. Now, there's a lot of questions that follow this format on worksheet 4, but they just all, like I said, they follow the same format. It's just a lot of practice of the same thing.